This is lesson 3.7. The standard that we're working with is ACED2, absolute value of equations. Up to this point, we've solved equations with variables on both sides. We are now going to be looking at solving absolute value equations. We will save the inequalities till the next unit that we work with. First thing we have to do is isolate our absolute value. What does it mean, isolate? That means the absolute value needs to be totally by itself. Then write the equivalent pair of linear equations. Now, we're not going to talk about the inequalities at this point, but the equations. So how do you solve an absolute value equation? If we have the absolute value of x plus 2 equals 9, first thing we have to do is get this absolute value by itself. We're going to use our subtraction property of equality and subtract 2. When you do that, we are going to be left with the absolute value of x is equal to 7. Well, if the absolute value of x is 7, the definition of absolute value says that x can actually be 7, or x can be equal to negative 7. So we have two options. And if we are going to graph that solution, we would then put on a number line the point at negative 7 and 7. As you look at that, the key thing to remember is anytime you're solving absolute value, you have a possibility of two solutions. Notice I said possibility. It doesn't always have to be 2, but you have that possibility. When you go to do your check, you're going to plug in your number. So absolute value of 7, does it equal 9? Plus 2. Absolute value of 7 plus 2 is 9. What about if we plug in our negative 7? Absolute value of negative 7. Well, when we look at the absolute value of negative 7, it's still 7, and it checks. So it's your turn to try. If you want to pause the video, do that. Please write this problem down, absolute value of n minus 5 equals negative 2, in your notes. First step, add 5. We have to get the absolute value by itself. When we look at that, we now have absolute value of n is going to be equal to 3. If the absolute value of n equals 3, what are the possibilities? The possibility is that n could be equal to 3, or n could be equal to negative 3. And again, if we are going to graph that on our number line, we're going to have down at negative 3, we'd put a point, and at positive 3, we'd have a point. Now, the check, we're going to plug in place of the absolute value of n, we are going to plug in, maybe the first time, 3 minus 5. Does it give us negative 2? And our other solution is the absolute value of negative 3 minus 5. Does that also equal negative 2? This is the question that we are looking at. Absolute value of 3 is 3. 3 minus 5 does equal negative 2. Absolute value of negative 3 is 3 minus 5. Yes, again, that equals negative 2. Our two solutions are 3 and negative 3. Key thing to solve absolute value. The absolute value equals b, where a represents a variable, and b, notice, has to be greater than 0. You have two answers. Absolute value of that variable could be equal to b, or the opposite of that. As you look at these equations, this whole part is inside x minus 2, the absolute value. So when we set up our equation, we're going to put x minus 2, that whole expression is equal to 3, and, keyword and, x minus 2 will equal negative 3. It's always the number and its opposite. Here we are now adding 2. When you add 2 on both sides of your equation, in both equations, our first equation is going to give us the answer of x equals 5. And the other answer is that x is equal to negative 1. As you look at these two and we substitute in to do our check, if we are checking absolute value of 5 minus 2, does that equal 3? And this is the absolute value of 3, which checks, it does equal 3. What about if you get negative 1? Well, the absolute value of negative 1 minus 2. The question is it equal to 3? Well, inside this parenthesis, remember that's plus a negative, we would have, and not inside that parenthesis, inside our absolute value, the absolute value of negative 3 does equal 3. And again, it checks. So I'm going to do this next one. I'm going to show you how this looks. We are going to first start with writing our two equations, x plus 1. Everything stays the same inside here, just like it did here. Inside that absolute value, it stays the same. And we are also going to have it equal to the opposite. We are going to subtract 1. As you are subtracting 1, x is equal to 6, and x is equal to negative 8. And if you plug that in, 6 plus 1, absolute value, does it equal 7? The other question we're trying to figure out is what if we plug in negative 8 plus 1? And again, here we'd have negative 7. The absolute value of negative 7 does equal 7. And the absolute value of 7 is also equal to 7, and it checks. So please try this last one. I'm going to give you a few more examples. We will look at what our two solutions should be, so be ready to talk about those in class tomorrow. Again, you're going to see more problems. What happens when you have something equal to 0 with absolute value? Well, you can't have two solutions because you won't have an opposite. There's only the one solution. Absolute value of x minus 4, we're going to add 4. And our only solution that will make this true is that x is equal to 4. Here you have another situation where you're going to have to do a two-step problem and another two-step problem. Again, keep in mind what's ever inside that absolute value, you're going to write that the same, is equal to the 5, and keeping again inside that absolute value, 2x minus 1 is equal to the opposite, negative 5. Your steps are still the same, so that you are going to add 1 to both sides, and 2x is equal to 6. And over on this side, adding 1, 2x is equal to negative 4. Then we're going to be dividing by 2 because of our division property of equality. And our two solutions are x equals 3 and x is equal to negative 2. Does it check? Again, when you go to do the check, you got to go back to the original problem for the check. You are plugging in absolute value of 2 times 3 minus 1. And the question is it equal to 5? And on this side, if we wanted to think the absolute value of 2 times negative 2 minus 1, is it again equal to 5? And that's the question we're checking. 6 minus 1, absolute value of 5, does check, it gives us 5. Negative 4 minus 1, absolute value of negative 4 minus 1 is the absolute value of negative 5, and that also checks. I want you to read this problem carefully. It says, multiple choice. Starting 100 feet away, your friend skates towards you and then passes by you. She skates at a constant speed of 20 feet per second. Her distance, d, from you in feet after t seconds is given in this equation. So what does the d stand for? It's the distance from you. What does the t stand for? Time in seconds. And the question is, at what time is she 40 feet from you? So when we set up our equation, what we're really trying to say is that d equals 40. So we're really trying to put in 40 here. So 100 minus, absolute value of 100 minus 20t, one possible answer is that we would have 40. The other possible solution is negative 40. What do we do to solve it once we have 40 and we've gotten rid of our absolute value? We're going to subtract 100 from both sides. gives us negative 60 and a negative 140. Once we've done that, our next step is to divide both sides by negative 20. Gives us 3 and 7. So we would say, at what time is she 40 feet from you? At 3 seconds and at 7 seconds. So our choice would be C. As you read this next question, this is the last one that we're looking at. Another friend's distance d from you in feet at t seconds is given as this equation. D is equal to absolute value of 80 minus 5t. The first question, what does the 80 stand for? So if we look back at the last example, the 80 is going to stand for, thinking about that problem, 80 is the number of feet, 80 feet away from you is how far your friend is. What does the 5 stand for? And again, if you're looking at that, it's 5 times the time. In our last example, the 20 is what we used, and that's how fast they were skating. So now we would look at the 5. That's going to be, in this case, the 5 feet per second, and it's the speed of our friends skating. That's how fast they are going. And the question says, at what time is she 60 feet from you? So if we're thinking about this equation, what we really want to put is 60 is equal to the absolute value of 80 minus 5t. So that when we go to solve that, if we're looking for times, and notice it says times, not time. Remember, if you think about this situation, here you're standing, this is you, your friend approaches going at that speed. She was 80 feet from you, and now she goes past you. So we're looking for the 2 times, and in this case, 60 equals 80 minus 5t. The second one is going to be 80 minus 5t, and this time instead of equaling 60, it has to equal the opposite, negative 60. You're going to continue to solve this equation by subtracting 80 on both sides. As we subtract 80, we're going to have a negative 20 equals negative 5t. Here when we subtract 80, as we subtract our 80, we're going to have a negative 140 is equal to the negative 5t. If you are solving this, we should divide both sides by negative 5 so that our time actually comes out positive. Our first one is going to be 4 seconds. And our second answer, as we are taking a look, when we divide by negative 5. So as we solved our last one, again, negative divided by negative, t is equal to, 5 goes into 14, actually 2 times. We're left with a remainder of 40. 5 goes into 40 8 times. So we would have 4 seconds and at 28 seconds. We will talk more about these in class tomorrow and go through more examples with your absolute value as you practice.